Hello everyone, welcome back to my review video for AP Calculus. This is Unit 2 about derivative. So let's talk about the notation for derivative. There are three, one from Lagrange, one from Leibniz, and one from Newton. And the notation for Lagrange is f prime of x, f prime of x. The notation from Leibniz is dy dx. The notation for Newton is y, and there's a dot on top of the variable. These two you'll see most common. And this one is uncommon in calculus, but common in physics. Okay, let's talk about what is derivative. Let's talk about the definition of them. So there are actually two definitions to two limit form definition. The first one is f prime of x equal to the limit of delta x approaches 0 of f of x plus delta x minus f of x, all divided by delta x. But your teacher may write it as the limit of h approaches 0 of f of x plus h minus f of x divided by h. Both are fine to use. And let's talk about the alternative definition. It's f prime of x equal to the limit of x approach some number c of f of x minus f of c divided by x minus c. What does this definition really mean? Well, does this look like dy over dx to you? Well, in fact, it is. But when dx is approaching 0, so what this is the slope. And the first definition is basically when the slope of the 2 points, and these 2 points are infinitely close, and you give the slope at a point. The second definition talks about when some numbers x is approaching c, and we calculate the slope of it, and that's our slope at that point. And what derivative is instantaneous rate of change. It's happening at that certain time. And in calculus, we can say that it's the slope of the tangent line. At a point. Okay. Let's talk about using the definition of derivative to calculate the derivative of x squared. So we will use the most common definition, which is the first one here. And I want to use h because it's a little bit shorter. So the limit of h approaches 0. F of x plus h is x plus h squared. You're basically substituting x as x plus h and minus our f of x, which is x squared, and all divided by h. Okay, let's expand this. That's sum of squares, so that's x squared plus 2xh plus h squared minus x squared, all divided by h. Well, x squared and negative x squared, they cancel out, so which leaves to 2xh plus h squared over h. And I forgot the limit sign here. Limit of h approaches 0. And limit of h approaches 0. Which, see here, we can cancel out a h. So that's the limit of h approaches 0 of 2x plus h. Since the limit is approaching 0, h is also approaching 0, so which that's equal to 2x. And we successfully found the derivative of x squared. And now let's approximate the derivative using a table. So what we're gonna do is choose 2 points. Choose 2 points. That's closest to the target value. And one is smaller than your target value. One smaller, one is a little bit bigger. And how we calculate the derivative? Well, we're gonna use the average rate of change, which is m equal to delta y over delta x. And we are using this data to approximate the derivative at that point. The smaller the difference, the more accurate the derivative is. So let's look at an example. This is from EP Calculus AB and BC FRQ question 1, and it's part 1. It's perfect for our example here. Approximate C prime of f using the average rate of change of C over the interval from 3 to 7. Show the work that leads to your answer and include units of measure. So we're gonna do C prime of f is approximately equal to, well, it says approximate. So you're gonna use the approximate sign. Equal to, let's use our slope formula, delta y over delta x. Well, we're using C of 7 and C of 3 is mentioning here. So C of 7 minus C of 3, all divided by 7 minus 3. That's equal to 69 minus 85 divided by 4. That's equal to -4. Don't forget our unit. What's our unit? Well, the numerical value is delta y over delta x. So our unit should be y divided by x, which is degrees Celsius divided by minute. You can say degree Celsius per minute. Okay. How do you find the equation of tangent line at point x0, y0? Well, we can use the derivative to find out. So what we're using is the point slope form. Since we're given the f prime of x, we're giving the y value, and we're giving the x value. So let's use in point slope form. So y minus your y value is y0. That's equal to our slope. What is our slope? Our slope is the derivative. So it's f prime of x0 times our x minus our x value here is x0. And that is our equation of tangent line. Pretty simple. What makes a function, let's use differentiable. What makes a function differentiable? Well, it has to be continuous. And it must not be a cusp, which is a sharp corner. And the tangent line cannot be vertical. Can be vertical. What does vertical mean? Well, it's like this. So which means that it's delta y, delta x is equal to delta y over 0. That's undefined. So it's not differentiable at a point that the tangent line is vertical. So here are 2 examples. Here's a cusp point of f of x equal to absolute value of x at x equals 0. And there's a discontinuity. And we see here, at this point here, at the left side, the slope is equal to -1. And at this side, the slope is 1. We call it that the definition of derivative is a double-sided limit. And the left-sided limit and the right-side limit are not equal, which means that the limit does not exist, and that this point, x equal to 0, it is not differentiable. And here's one example of discontinuity, is jump discontinuity. You'll see it in piecewise function. And in fact, all three discontinuity will lead the function at that point not differentiable. Removable, there's jump, and there's infinite. All three will make it not differentiable. Okay. So these are what derivative mean. And let's actually calculate some derivative. Let's talk about some common derivative you should remember. The derivative of x to the n power, n can be any number that n is not equal to 0. Any number n is not equal to 0. That's equal to n times x to the n minus 1. And what happens if n equal to 0? Well, x to the 0 power is just 1. It's a constant. And now let's talk about derivative of constant. And if you recall, the graph of a constant function is horizontal line of slope equal to 0, and we can tell the derivative of a constant function is equal to 0. What's the derivative of e to the x? Why we specifically mention e to the x here? Because it's a special number, and the derivative must be very special. It is in fact e to the x. And natural log of x, I pronounce it as ln of x, is equal to 1 over x. These are special cases of exponential function and logarithmic function. And the general derivative we will cover in next unit. And let's talk about common derivative rules. Let's talk about constant multiple rule. Let's say you have a constant that's multiplied by a function, and we're taking the derivative of it. It's just k times derivative of f of x. This constant here does not do anything. It just scale up the graph and also scale up the slope. Let's talk about sum rule and difference rule. I write it using plus or minus. Show that sum and difference rule are basically the same. So that's equal to derivative of f of x plus or minus the derivative of g of x. And product rule and quotient rule. These two rules are longer than the previous rule, and the derivative of f of x times g of x is equal to f prime of x, g of x, plus f of x, g prime of x. And the quotient rule is probably the longest rule in derivative you will learn. It's equal to, let's write it in denominator first. G of, let's rewrite it. G of x squared times f prime of x, g of x, minus f of x, g prime of x. Usually, if the denominator is really simple, let's say it's some function over x, I will actually write it in fx to the negative 1 to use the product rule to make it a little bit more simpler. And to also speed up your calculation. Okay, trigonometric derivatives. We will learn all 6. The derivative sine of x is equal to cosine of x. The derivative of cosine of x, guess what? It's negative of sine of x. The derivative of tangent of x is equal to secant squared of x. Well, it's actually one of our practice problems. We'll talk about it a bit later. the derivative of cotangent of x equal to negative of cosecant squared of x. The derivative secant of x is equal to sine of x over cosine squared of x, and which is equal to tangent of x times secant of x. Secant of x. I will usually only memorize this one and instead of this one. Okay. And lastly, the derivative of cosecant of x is equal to the negative of the cosine of x divided by sine squared of x. And that is equal to the negative of the cotangent of x times cosecant of x. All right. And let's practice. And we got 3 practice problems. So the first example is the derivative of 3x squared plus 2x plus 1. What is it equal to? That's equal to the 3 times the derivative of x squared. See, that's the constant multiple rule, and we will use the sum rule. 2 times the derivative of x plus the derivative of 1, which is equal to 3 times, you move the exponent to the front. And that's 2x. And you subtract exponent by 1. 2x to the first power. And plus 2 times x is equal to x to the 1 power, which leaves us to 1 times x to the 0 power. 1 minus 1 equal to 0. So it just equal to 1. And plus, remember the derivative of a constant is equal to 0, which equal to 6x plus 2 if you simplify it. Okay, let's talk about another example. See here, it's the product of 2 functions, x squared and sine of x. So we're going to do here, we use the product rule. So the derivative of fg is equal to f prime of g plus fg prime. Notice that I do not have to write the parenthesis x here. We just like simplifying it. Okay. What is this equal to? We can do derivative of x squared times sine of x, and plus x squared times the derivative of sine of x, What is this equal to? 2x sine of x plus x squared. The derivative of sine of x is equal to cosine of x. And that is our answer for this derivative. And lastly, we'll derive the derivative of tangent of x is equal to secant squared of x. What is tangent of x? Tangent of x equal to sine of x divided by cosine of x. So what this really means is that we're taking the derivative of sine of x divided by cosine of x. Okay. What we're going to do, we use the quotient rule. Okay. That's equal to, let's write the denominator first. Cosine squared of x. Remember, it's just the denominator squared. It's not the derivative of the denominator squared, just the denominator squared. And the derivative of sine of x times your denominator, which is cosine of x. And see, quotient rule is really long. And we're gonna minus sine of x times the derivative of cosine of x. And that's our quotient rule. And let's keep simplifying it. Derivative of sine of x, recall, is cosine of x. cosine of x times cosine of x. So it's cosine squared of x. And you minus sine of x times the derivative of cosine with x, which is negative the sine of x, over cosine squared of x. If you see here, do not simplify this thing first, okay? See, that's equal to cosine squared of x plus sine squared of x divided by cosine squared of x. What is this? This, the numerator, based on Pythagorean identity, is equal to 1. So that's equal to 1 over cosine squared of x, which is equal to secant squared of x. And we see here, the derivative of tangent of x actually equal to secant squared of x. And that concludes my review video for AP Calculus, Unit 2, Derivatives. And thank you for watching this video. And please like and subscribe. And I'll see you next time.